All right, so for this question, we are given the function f right here, and we're asked to use it to find its inverse function and then graph both functions on the grid. So the first thing to do is to take the original function f and just rewrite it with y, like that, okay? And then we're going to switch the x and the y, like literally just swap their places because that is the most basic thing to understand about the relationship between inverse functions is that their domain and range are opposite. So it makes sense to switch the x and the y's. So now this is actually the inverse. So this is the original function here. Just give me some label. Function f of x, right? And then the inverse of f, okay? That's what we have here. Now we want to take the inverse, so this is the inverse right here, but we need to put it into function notation. So we're going to solve for y by doing inverse operations. So I'm just going to do what I need to do to get y alone on one side of the equal sign. So I'm going to just start by writing this equation in the opposite direction, which I can do because an equal sign works in both directions. So I'm just going to write the 1/3 y minus 5 part over here, and then the equals x on the other side. And this is because I eventually want y on the left. I just prefer it that way. Now I'm going to add 5 to both sides of this equation so that I can get this 5 basically moved to the other side of the equal. So I'm just going to add 5 here on the left, and as long as I do the same thing on the right, then all things are equivalent. So -5 plus 5 just becomes 0, and then I don't really need to write the 0. So then I have -1/3 times y equals x plus 5. All right, next I'm going to multiply both sides of the equation by a -3, and that will get rid of this lead coefficient. Okay, so if I multiply this version of the equation by -3, then also do the same thing over here. Okay, so everything's still equivalent, right? Here's the -3 that I am multiplying on both sides because I don't want to change the value. So -3 times -1/3 would become +1. Okay, and then 1 times y is just y. So now the left side is just y like I wanted. And then on the right, I need to distribute the -3, multiply it to both x and 5. So -3x, and then -15 because -3 times 5 is -15. Okay, so now that it's solved for y, I just need to give it a new name, and that's where we call it f inverse. So that's the new name notation for the inverse of a function. F to the, looks almost like an exponent, but no, that actually reads f inverse, or the inverse function of f. Okay, so now that we have it, we just need to type in the right side of this as the answer for this part of it. I'm not sure what just happened. I pressed enter and something went crazy. Hopefully we'll get it back with the same numbers, and we'll try that again. Oh, okay, good. All right, so that's the first step. The next step is to draw both f, the original function that they gave us up here, and the new inverse together. And this is because what we want to see is that the two functions are symmetric across the identity function where y is equal to x. You know, that's the nature of inverse functions, is that if you swap them across or flip them across the y equals x line, oops, that was an accident, you'll see symmetry there because the domain and range have switched. All right, so we're going to start by graphing f, the function f. We can use the slope-intercept approach, right? Because this is in the form of y equals mx plus b, where your slope is the coefficient of x, and then -5 would represent your y-intercept. So I'm going to go to -5 with the graphing tool for the line, a line graphing tool. I'm going to start at my y-intercept of -5. Then I'm going to use the slope to go a rise of +1, and since I went positive for the rise, I'm going to need to go backwards for the run so that I get a negative slope line. Remember, negative sloped lines go downward from left to right, or are decreasing from left to right. So from, I'll just check it again from this point. If I were to go down 1 and to the right 3, I would end up here. Or if from here I go up 1 and backward 3, I end up here. Okay, so that is the graph of the original function f. Now I'm going to graph the inverse. Now notice that the intercept for the inverse is not showing on the range of the grid available here. So I'm going to have to use a different approach rather than using the y-intercept format. So what I can do is just think of an x value that is on the picture or within the range in the grid, um, and plug that in and see what ordered pair I get. And I'd like to pick an x value that will give me a y value that is somewhere between -5 and 5, so it also appears on the graph. Now I noticed that if I picked -5 as my x value to plug into this function, and I plug in -5 here, let's just do that down here. So for the inverse function, I'm going to let x equal -5, then what is y equal to? That's what we're trying to figure out because we want to find an ordered pair that we can graph, and then we can always just use the slope, which is -3, to get to a second point. So as long as we can find one point, we're good. So I'm going to plug in -5 to this function, so I'll have negative y equals -3 times -5, which is the x value I'm replacing here, right? And then I'm going to subtract 15. So I'll get y equals +15 because -3 times -5 is 15. And then y equals 0. All right, so I get this point, this ordered pair, -5, 0. So I'm going to go ahead and use that for my graphing of the inverse function. And then I'm just going to use the slope of -3 to go down 1, 2, 3, and to the right 1. And that ought to do it. So let me just make sure that I did that right, because here's my slope again. Remember, that's a rise of 3 and a run of 1, and I just have to make sure that one of those directions is in the negative direction. So starting from my point at -5, 0 on the x-axis, I go down 1, 2, 3, and to the right 1. So that looks correct to me. I'm going to go ahead and submit it, and that's it.